Okay, it ran out of space on me again. I'm sorry about that. Again, first thing I have to do, create an equation, this equals to this. Second thing, cancel the linear equation so that we can put it together with the quadratic equation. Okay, maybe I should write it in here. Create an equation with both equations in here. Then cancel one side. And you usually want to cancel the linear equation to make it easier. Otherwise, you're going to end up with a negative x squared. The next thing is to solve for x by factoring or with the quadratic equation. Either one is fine. Solve for x. Again, I did it with factoring, but you can also use the quadratic equation if you want. And the last step is to replace the first value you found, usually x, to find the second value of the coordinate. And in most cases, it will be y. Okay, so those are the steps to follow. Let's do another example. So we have y equals x squared plus 3x plus 5. And y equals negative 2x plus, no, minus 1. Sorry about that. As my students say, hi teacher. Minus 1. And so we start. The first step is to substitute the y, right? To create that equation. So it's going to be, I'm going to put this one first now. It doesn't matter, but so that you can see the two different ways. So I'm going to write the first one and then substitute that in the y, which is the negative 2x minus 1. I cancel the linear equation, okay? That way I'm going to stay with this positive. So plus 2x plus 1 plus 2x plus 1. And that's going to be x squared plus 5x plus 6 is equals to, this cancels and I get 0. Now that my quadratic equation is equals to 0, remember that it has to be equals to 0, I can figure out either using the quadratic equation or factoring. And I noticed that if I multiply these two factors, that if I find two factors of 6, meaning 2 and 3 or 1 and 6, the 2 and the 3 give me the 5. So it's easier to just factor instead of using the quadratic equation, right? So x plus 2, x plus 3 will give me this product. And so how can I what's the value of x that will make one of these factors 0? So x can be negative 2, because negative 2 plus 2 is 0, or negative 3. I already found the value of x. And again, I'm going to have two solutions, meaning that the quadratic equation and the linear equation will meet at two different points. But I still need to figure out what y is. And so I'm going to use, again, it's easier to use the linear equation, but you can use any of the two. Negative 2 times negative 2, which is my value of x, minus 1. Negative 2 times negative 2 is positive 4, minus 1, which is 3. So that's the value of y. And then y is equals to negative 2 times the value of x, which is negative 3, minus 1 is equals to negative 2 times negative 3, positive 6, minus 1 equals 5. So Those are my two solutions. Those are the 2 points where my quadratic and linear equations will meet. Okay, this is what we're looking for. Okay, let's do one more. I have y equals x squared plus x plus 5. Y equals negative 3x plus 1. First thing, to create an equation between those two by substituting, I'm going to put x squared plus x plus 5 is equals to negative 3x plus 1. The second step is to cancel this. So I'm going to add and subtract. Add 3x, subtract 1, so that this can cancel. And I'm going to have x squared plus 4x plus 4 equals 0. I go no GCF, but then this is a perfect square and this is a perfect square, so it possibly is the perfect square. And so I noticed that if I take half of this and raise it to the second power, that will be equals to 4. So x plus 2 is going to be a perfect square, so that works. I take the square root of both sides, and so it's going to be x plus 2 is equals to plus minus 0. Remember that when we are adding and subtracting 0, we're going to end up with one answer only. And so, why? Because if we have negative 2 plus 0 is negative 2. Negative 2 minus 0 is still going to be negative 2. Okay? So usually, actually, always when you have 0 on the other side and you have a perfect square on this side, you will end up with one answer only. So, guess how many solutions we will have? Okay, so and how do I find that one solution? By replacing the x on one of my two equations. And so I'm going to put, instead of x is negative 2 plus 1, and negative 3 times negative 2 is 6 plus 1, which is equals to 7. That means that my two equations will meet only in one place, which is at negative 2, positive 7. Only one solution. Okay. One more example. So again, we're going to create by substituting. So I'm just going to send it to the other side. Create one equation. And so I'm going to cancel this so that this is equals to 0. That's what we need. And so x squared minus 3x plus 15 is equals to 0. And so I tried to figure out what two numbers multiply equals 15, but added equals negative 3. And we can find something like that. We can use completing the square, but remember I told you before in the previous lesson that if you have an odd number in here, that it makes it a little bit more complex because of the fractions. So you would use the quadratic equation instead. So to figure out the value of x, I'm going to write x is equals to negative b. You can just change the sign, that's fine. Plus minus the square root of b squared minus 4ac all over 2a. And in here you will have positive 3 plus minus the square root of Negative 3 squared is 9. Negative 4 times 1 times 15 is negative 60 over 2 times 1 is 2. What I want you to notice is that in here, you will have equals to negative 51 inside of the square root. And once you get to a negative, that means that you're going to end up with an imaginary number because of this negative. So guess what? I just want you to stop right there. I don't even want you to tell me the solutions for this, because it's going to be imaginary, and that means that my graphs will never meet. My line and my quadratic equation, when I graph them, they will not meet. So we'll just stop. Whenever you find a negative inside of the square root, or whenever you have an imaginary number, that means that we don't have a solution. So you will just put no solution. You don't even have to continue all the way. Okay, so that's gonna be all for today. Again, sorry that I had to do 2 different videos. I ran out of space again, but hope this helps.